Hey, welcome back to Made Up of Wires, where we're going to be decompiling Castlevania Symphony of the Night. Good to have you back. You can go to soten.z.dev to learn more about the Symphony of the Night decompilation project. We've been looking at Olrox, making pretty slow progress on different Olrox functions, going about it slightly differently than I've done some of the other ones. Usually, I'll get to some of the easier stuff first, but I've been kind of diving right in and getting into the meat of this one. And so we're looking at boss overlays. If you're not familiar with how Symphony of the Night is architected, boss overlays take the place of a stage overlay. An overlay is just an address space in memory where certain things of different categories live. So there's an area for the main game, there's an area for Richter, there's an area for the weapon, for your left hand and right hand, for your familiar, and for the stage. And so bosses are in that same stage set. They live in a different directory structure than the other stages, but they do take a place of a stage. And so they have a lot of the same elements of a stage and share a lot of those same features. And in the case of Olrox, or any boss really, we have one function that acts as kind of the main controller for all of the scenario, setting up the boss fight and looking for the win condition or the loss condition in that stage. And then we have an entity for the boss itself, and that's what we've been looking at. So the scenario function is actually the most complicated function in this particular boss fight, and I think that was the case for Doppelganger as well. And Olrox, the Olrox entity, is the second most complicated, and that's what we've been working on. So we're going to go into that. We use decomp.me for most of that work, and let's just dive right in. So we have a function. Let's see if I'm at the right one. I think so. So we're at about 94% of a match on the PlayStation. We're doing the PlayStation and the PSP version at the same time. And so we have to get it working and compiling on both. I'm going to spend most of the time, I think, on the PSP version. One of the things that I notice right offhand, though, is we actually have a ton of space that's reserved on the stack for something, and we might not actually be using it. So it looks like about 60 in hex. So what is that? 64, 80, 96 bytes that are just either going unused, or we're not using them for the correct thing, or these are just completely backwards. It might just be backwards. We'll see. We're going to go back over here. Eventually we need to get to the point where we're assigning the right variables to things, and that will change things a little bit. We actually are doing pretty well on this side. Our stack space is 80 bytes over here. We have 96 bytes on our side. So really just getting rid of a handful of variables looks like what needs to be done. I guess good to have you back. I'm going to save the stuff at the top for a little later. There's some code up at the top that appears to be dead code, I think. We'll find out, I guess, as we go along. I'm going to leave that for now. We use M2C to give us a first pass at what might be going on here, and M2C has completely ignored a bunch of the stuff going on there. So yeah, like I said, I'm going to leave that for now. We'll get back to it when everything else is working. Because we don't have the stack quite correct, we're going to get a bunch of stack offsets that are incorrect. I'm going to ignore most of those as well. And the first thing I'm going to do, it's been a while since I've looked at this code, I'm going to go back and just try to find areas where the instructions are obviously wrong. So I'm going to be ignoring registers, most immediates, not all of them, but most of them. Moves that show up, usually those are just a side effect of how the code is written, so I'm going to ignore that as well. So these RS is all that is ignored. Something like this on 87. I'm somewhat interested in. This might be a mistake in how jumps were, code deduplication was done on the GCC side, because I originally started with GCC here. We'll have to go back and look to see if that music ID is correct or not when we go back to the PlayStation version. There's going to be symbol differences between the two versions. I'm not concerned with those either. This is a stack space issue versus a register variable. Not going to worry about that either. Really, I'm trying to find large-ish sections where things look wrong, and this is the first one that is standing out to me. So we have these SEH instructions. They're used for converting 16-bit to 32-bit signed values. They only appear on the PSP version. The PlayStation doesn't have this instruction, and GCC emulates this in different ways with the instructions that do exist. But this points out that we have translation going between 16 and 32-bit values. And so it appears that S7, which I'm assuming is this POSX variable, which is currently our S4, is probably a 32-bit value, and we currently have it as we have it at S32. So maybe it's a 16-bit value, and this could be a different. It could be a different variable from what I expect. So let's work on that. And so I'm going to look at S7 and S4 registers and see if they're used the same way throughout and in the same place. And what I want to see is that where the highlights are happening in approximately the same places. So down here on 117, we do see those again, but then a little further down, we don't see that anymore. So this looks like to me, so the S7 register is being put into the S0 register. Whether or not that's another variable, not quite sure at this point. Go back and look, but I want to solve this first. And then we're assigning or passing that as the first argument to the absolute value function. So it looks to me like this should be POSX and not global POSX. And that should match up a little bit better. And then down here, we kind of have the opposite. We're passing POSX. Let's get side to player, take 2. I don't think it takes 2 args. It takes 0 args. So let's fix that globally. The reason that M2C will sometimes put args for a function that doesn't have them is because we don't provide a function signature, because we don't have function signatures in a lot of the code. And so in C, the default function signature is to take an arbitrary number of integer-sized parameters and return a integer. And so if there are values that are in the A0 and A1 registers, M2C will assume that those are arguments to that function. So I'm going to use a regular expression and look for cases where we're passing an arg there. So those will be wrong. that's all. And already we got to 92%, not doing a whole lot. So that's good. So let's go back up here and see. It looks like our variable change now we're S6. These align a little more closely. This variable, though, almost certainly is a 16-bit value. And the reason I am suspecting that is because we get the SEH instruction before passing it into the absolute value function as an arg. And that would happen if the compiler thought the absolute value function took a 32-bit integer, but we were only passing a 16-bit value. So I'm going to demote that. And that will break some other things. But I'm not too worried about that right now. I do have my SEH instructions. I'm not getting it up here yet. But actually I did get some of them. And we'll come back to it later. Likely pause Y, then is sign 16 as well. And that's going to change some things. Some for the better, some for the worse. Let's keep going and see if we're using that variable consistently other places. 130. It's like not. This looks like it's not under our control, so I'm not going to worry about it too much. I'm not sure why the compiler is moving this into the S6 register. It doesn't make a whole lot of difference, but all right, 223. Lost my highlight here. It looks like this is going, instead of global POSX, we're going to just POSX. Line 130 uses 6 and 134 uses 6U. Does that matter? Yeah, probably. We can go back up and look at that. In this case, it doesn't, because an unsigned 6 and a signed 6 end up being the same thing. It definitely depends on the context. Hey, Roming. Yes, they definitely can. So Roming's pointing out that this chain of else if else can be part of this original. Let's look at that and see if it changes. What I want to see is, I think that would be fine. Let's look at 123. The cast here for unsigned is odd. But yeah, so the thing that may or may not cause this to work or not work is where the jump instructions go. Let's go back. I just want to see what the number here is. 282 versus 282. Yeah, so no difference. So yeah, I like that as well. I think it's structurally neater. We can actually chain it, it looks like, with this one as well. Good call out. Okay, I think I was down here at 219. So this 219 here looks like it's probably that same POSX. The ordering of these is odd. So we're doing this and and I wonder if this is happening. I kind of remember doing this. This would be quite a bit to have in the and. It doesn't mean that it's not happening that way. It's just more than I usually would like to have up there. And it's also possible that the and equals is happening here, and the plus plus is happening here. We might be having a explicit. How'd this go? No, so we need the okay, so that is the right order. Looks like there's just an additional move. So I'm going to chalk this up to this being the correct order. It's possible that this S4 plus plus, we could try it in here. Yeah, my guess is that something else will trigger. Roaming suggesting equals plus plus var S4 and 3. I would hate that if that's the case. Yeah, that when you're not doing one of the mutating operators, you get a lot more masks. What really is happening is this move is being put in place. My guess is that the move is there for padding. Sometimes I don't know what the heuristic really is for why this isn't going directly to the S3 register instead of going to A0 and then into S3. So I'm going to not worry about that at the moment and assume that there's some other issue somewhere else. Sometimes it's just a comparison operator somewhere else or incorrect variable being used, and then those fall into place. So I'm gonna ignore that for something more fruitful. Let's go back and get our registers highlighted. Which one? Eventually it's going into S6. I thought I was looking at S7 though. Alright, 248, I'm using the wrong value, or the compiler has decided to use that for something else. Looks like this is happening in line instead of going to a variable. The mask here is weird. Oh, duh. When you're explicitly checking against 0 as opposed to doing the not operator, you're going to get extra mask. But this looks fine then. And I lose my highlights? No, I don't. I'm looking good. Hey Eldritch, good to have you. Looks like a holographic emoji. What? Still Olrox. Olrox has been slow going. Whoever wrote Olrox, I'm not a fan of. He is a sly devil. Alright. This is interesting. My guess is this is if not entity we're breaking? Or Varus 4 is not a thing? Let's look at that. What if we break? So is if entity ID, I think that might be part of our termination condition. Let's try that. So this looks like it's counting counting up to 8 entities that aren't set. Yeah, that's not quite right. And the question is it terminating early if they aren't set? It looks like it is. So I do think that ends up being part of it. Let's try. This is odd too. A lot of this is just strange. So in the original generated code that M2C interpreted, we're basically checking for this expression to be non-zero. Interesting though. Oh yeah. Yep, that's fine. And every loop, regardless, as long as that is non-zero, so that's our less than 8 check, we're checking for entity ID not equal to 0. And that's not saying that this M2C interpretation is even correct. It might not be. The var S4, in this case it's S3, that's not terribly important. Yeah, I'm not sure why it wouldn't be written like this. You never know. You never know. And again, it could be variable related. It might not be. I'm gonna go back to looking for my pos x's though. Yeah, here, so there is a second variable. Drat. So there are some cases where I'm using S4 where S6 is used. And so here we're even assigning it on 219. We start with S7 variable, so this pos6, but then end up assigning it to global pos(x), it looks like. But this would mean global pos(x) is also an x. Yeah, too many translations. I think S6 might be being used there as a just a placeholder, and down below where we're using S6 again. So I'm going to assume that global pos(x) is S6. Let's start putting register annotations here. I don't know that I don't want to do that quite yet. So in this case, though, I am using this incorrectly. We do need to find out what S6 is. Let's find, I guess, where global pos(x) is and see if that is S6. It is not. Right now it seems to be S2. Let's find out where else S6 is being used then. In this case, yeah, it is room pause X. Good call. I'll replace it. In the terms of this particular stage, since it's all rocks, there is only the room. All right, so S6 we have down here, 378. It's ephemeral. Give me 1 second, I need to take a phone call. I'll be right back, and we'll be back with more decompiling. Stand by. Alright, we're back. I just want to make sure everything was okay, which it appears to be. Okay, so we have S6 down here again, and right now... Oh, I think I talked about that already. Yeah, it's just a random variable in the middle of... Actually, is it being assigned to self? Yeah. So yeah, we can't trust that. So by this point, it looks like S6 is broken already. And when I mean broken, it's just not associated with the same thing anymore. 111 up here. So player is S4. I think that we can confidently say that. And then we're loading something into S6. And it almost looks like player pause X. So we're pulling offset 2 from the player, which is pause X I high. I'm not sure though that that's actually going into a variable because we're not getting it from anywhere again, and we're overwriting it almost immediately with pause Y. Roaming is saying for the unsigned 16 cast down here that would the PSP combine that check into 2? I don't think so. There's a couple things though that are interesting with that. Is we have this S2 here. So we're setting room pause X to S2, and so that gives us pretty definitive evidence that room pause X is the S2 register. So I like that. So there's a couple things that could be going on. Let's see what happens if we make 64 an unsigned. Yeah, we just get an unsigned sign less than. Sign less than? Signed less than immediate unsigned? That's interesting. So we could mask it manually, but my guess is that that is not going to work either. Not at least in the way that I'm expecting it to. There's going to be a single... Let's put some friends in there. We get the single mask and then a sign extension. So the sign extension first. So we're promoting to 32-bit and then we're doing the mask. So that's not what we want either. So the unsigned 16 there seems to be the most obvious choice for an operator. And I'm trying to think what is that going to do? If we're casting as unsigned, if we're negative, I guess it's a shortcut for a negative check, because the negative check, or the 2's complement of that negative number is going to be greater than 64, so it automatically excludes everything less than 0. And if we check that specifically, we'll get the greater than or less than equal to 0. So because the optimizer is not on, we're not going to get that check. So I think this is a clever optimization from the developer rather than something that the compiler did. But I do want to go back and annotate this room pause X being S2. Oh, I already had that. Good for me. And let's look at the other one is maybe I should just spend time doing that, going through and fixing stack pointer offsets and starting to track variables. We don't have many variables, so it shouldn't be terrible. It's just not my favorite part of all of this. 117 seems weird for that reason. Yes. And I agree that absolutely does seem weird, and it actually knocks down our match quite a bit to switch to that. And I think I found that FFC0 is the same as negative 64. Grab my calculator. Yeah, that is negative 64. Yeah, I agree. So what would that even mean? That whole this whole construction is odd. So it's possible that I have the wrong type. It's possible that I have the wrong variable. Are we? Yes, I have the wrong variable. Good call. No, I have the right variable, S7. This is S7. So what are we doing here? My guess is that S3 is ephemeral. We're not actually assigning it to a variable, because we get S2 in ours. Oddly, on 116 we're getting that same S2. I think that's coincidental. Oh, yeah, I agree that's odd. Let's, I've been wanting to go take this back to the PlayStation version and see if we're any closer. So let's go over there and see what this looks like. We're actually did gain a % on the PlayStation. I don't necessarily think I'm gonna see anything obvious on the PlayStation version, but let's see what's going on here. So here we have a subtraction. V0 is pos x, and we're loading... No, it's not. V0 is... It looks like just pos x. We're loading it as unsigned. Is it possible that we have a different variable here that is unsigned? A0 is... So we're doing this late, and that's typical. So, okay, so we have a lazy subtraction. It's not done until we get in here. That's fine. And then down below, yeah, we're missing something there. It looks like a check is different, but the PSP should not be combining checks. So we're going to get these combined here. So in the PlayStation version, because both of these end with calling set step with the value 13, their expressions are going to be combined into one big condition. The shift by 16 is how the PlayStation is going to promote assign 16 to 32 bits. And so we have the room pause, that's fine. And var v0 is temp a0 getting set multiple times, don't worry about that. Being promoted to 32 bits. But then truncated back down to 16 bits. We never actually used var v0. This is the absolute value. Is it possible that this is a unsigned 16? I don't know. It's strange. Yeah, I guess it doesn't make sense. If it doesn't make sense, it's not true. As Judge Judy would say. So while this is producing the correct instructions, obviously something is going terribly wrong here. We're taking I high, so could we say less than? But why would somebody do this? Especially when this is the same as a 64. So this could be an optimization that somebody smarter than me decided to do. It could be I don't know what. We have another one of those down here as well. Same idea. Could it be the greater than equals that's doing it? I don't like it. I don't really have a... Unless pos x is an unsigned 16, I don't have a better alternative, though. And if it's an unsigned 16, we can't represent that anyway, but maybe they didn't know that. Maybe it was a mistake that it was an unsigned 16. And so these would have never triggered. Let's try that. I really don't want to... It's going to break a whole bunch of other things to make pos x an unsigned 16, but let's try it. For the sake of science. So we don't need the cast here. But we would need the mask. Okay, that works. So why would you mask this manually? This still doesn't work. Okay, so I don't like that, and it breaks a bunch of other things. So we're going to leave it like that for now. What's wrong? What did I do? The greater than equals is possibly interesting. That will change other things. I'm gonna leave it. I don't like it, and I think it's wrong, but it's closer. Let's go through and try to identify the registers for each of these variables. I think that's probably going to be the next most helpful thing. So I is usually S2, but not always. We need to find a for loop. There's probably the wrong variable up there, which is causing a bunch of things. So in this case, it's S1, and we're getting the right variable there. Entity on 73. Entity looks like S0. And that's not terribly uncommon. The variable I called var s4, that name came from the PlayStation. So it was var s4 there is S3. So what I'm looking for is, are any of these, are we running into duplicates anywhere? Step S does not look like it's used. This 211, we have a var S6 here, or a S6 register. So looks like this should be assigned 16. It is assigned 16. Okay, we're getting that. So that is S6. $315. S5. Our current GPU buffer. Maybe it's time to work through that since there's a lot of other noise. This is going into S0, which is our entity buffer, which this is not an entity. Going to the wrong wrong field. We're 4 bytes off on the field. Looks like it's going to the DR ENV. That's wrong. Oh, it's... I'm wrong. Display env is not a pointer, it's a struct. And it looks like this might be screen. So display, we're going to screen. Screen might be larger than that, though. Disp. It's still too far, so we're going like, let's look at rect. We're pointing at the width of this. Disp, which is a rect, right? Or disp.disp.width. Still wrong. Oh my goodness. I went the wrong direction. I've been going the wrong direction the whole time. Alright, let's try again. GPU buffer. So I'm in draw and the last field of draw and DR and in the last field of DR and oh, it's so hard. Get it. Okay, so what would we possibly be doing with this code? I don't know. Nor do I think it's quite right. So... and ultimately, it doesn't get used. But we are writing it to the S8 register. And then we have this unknown 8. Is this being used anywhere? Yes, it is. Okay, so we have whatever this was. We have a additional call to current buffer, which is wrong. And it looks like we should be going directly to this var. So this looks like an array to assign 32, so possibly an array to pointers. Did we look at this? Let's go look at this. See what this is. It looks like something that is just in the main. Oops, I want US star.map. So we don't have a definition for this yet, which is strange. Let's see if we can find where this is. It is being mapped to the same symbol on the PSP already, which is odd that I wouldn't see that symbol anywhere, including things that we built. Okay, so this is a PSP only symbol. We're only loading data from it, and only in this function so far. Let me look for a few more things. Okay, so we do have the symbol mapped to DRA. Hey, Kiritancito, good to have you back. Hey, Plaster, good to have you. Alright, so we have this variable. DRA knows about it, but it's never used in DRA, as far as I can tell. Let's look at it with that symbol. Can I do this search already? Oh no. So it's in BSS of DRA, and DRA is manipulating it in some way. And those functions match, and it appears to have a symbol name, but it's not being used. Okay, so let's look at what this function is and see if we can tell. Oh, the reason it's probably not being used is I'm guessing it's part of an array or some other struct. It's a little odd that it would be spaced the way that it is. We can look at this BSS layout and see if we can tell. What it's around. I think I did this already though. Okay, so let's look at where this function is. Render primitives. We want to see where in... We can tell approximately where this is being used. I'm not overly hopeful, but... so relatively early on, we're going to the current buffer, going to poly GT4. It's possible it's this GPU usage, but I don't know why we wouldn't have a symbol then. Let's open up that VSS again. And see where this is in relation. 4 dB8. 4 D8, sorry. So it's possible that this is part of GPU usage. Let's see what the size of that is. So sometimes when these symbols are mapped, their whole size isn't necessarily taken into consideration, and that's what it looks like here. So it looks like we have draw modes, GT4, G4, GT3, line, SP16, tile, SP and end. And so I think that's what's going on. And then we have an additional 4 bytes just to pad it out to align properly. To make it 28 or 8-byte alignment. So what I'm going to do is I'm going to look for GPU usage in config. We should see the PSP version of that. And we're going to set the size to 24 bytes. Set the size here. This size is just a comment, it doesn't do anything more. These have been turned into line comments. That's fine. So what this should do, if I regenerate the assembly, is this should give us these addresses in terms of that GPU usage instead of being their own thing when the assembly is generated. So instead of being this 91FCD4, it will be GPU usage plus 20. And I think that this function is now named... Oh, we can find it this way. Yes. So this is perfect. So it tells us, yeah, exactly what I was hoping for. So it's GPU usage plus 20. So we're loading that into a variable. We're doing a shift by 2, an add, and then a shift by 3, which tells us a little bit more about what's going on there. So what do we learn? We learn that this is a GPU usage. We should have that already in the context. We do. So we can reference it directly. And then the GPU usage struct as an env field, and that's what we're looking at. So we don't have a current buffer here. I think we're doing GPU usage .env. I'm getting rid of this. So we're missing the times 3 and, or sorry, times 8 and times 2. Let's look at how this is used elsewhere. It's not something that I'm familiar with, but maybe somebody else has figured out this pattern. And here we go, current buffer end. This looks great. So let's try that. Let's make a TRN, and we'll call it env. And we'll follow that same pattern. I still don't think that this is used. And it's pretty close, but not quite right. So we're doing the shift by 2 and then the shift by 3. But that isn't exactly what we want. If we multiply this by 4, it changes our value down there, but not necessarily where we want it. So what would we need to do? Our offset down below is wrong. So we're looking at gcurrent buffer again, which is a GPU buffer. There's 2 of them. So we're multiplying by 4 and then adding that value to itself, to the result of that. And then the shift by 3, which is a multiply by 8. So we're definitely in the wrong field. We're at offset 74. We should be much earlier. So we might be looking at any earlier is display and not environment. We don't really have any arrays in there. So what are we looking at? let's try a few of those tricks. I don't necessarily think that that's going to be exactly what we need. Ultimately, what's happening though is we're not using this for anything. That would be multiplied by 4. What is a trick? So the divide by sometimes generates additional adds. Oh, what about a multiplied by 5? Yep, okay, so multiply by 5 makes sense. We should do a multiply by 4 and then add one more. And then ENV is the wrong field, so we have to be much earlier. We have to be at 5C. So unless it is possible that that GPU buffer is different between, and maybe that's all it is that the PSP version of GPU buffer is different. Doesn't look like it. Yeah, so we're close, not quite there. Something is at offset 5C, and it looks like we're using it as not a DRN. Or we're in the first DRM, but that could be. And looking at the code field there, let's try that. Yeah, I'm missing something else. There definitely seems to be a multiplier there. Where the multiplier is, I'm not sure. ENV seems to be too far in. So let's try this. There are multiple buffers. There's not 5 of them, though. Yeah, that's way more complicated. Hey, Dizzy, good to have you back. Hey, Nick Me. So what we're missing here is what is causing this much earlier offset? Why is it being treated as something other than... I mean, I guess I know what the offset could be, but it seems like that should be a display environment. The display environment is not what we want. Possible though that I have the wrong field. I don't think I do though. Let's do one more check for other places that GPU usage env is used. This is the only place that it's used as an index anywhere. And what's unfortunate is that this is a dead store. So however it's used ultimately makes no difference because it's not used anywhere yet. Those changes do bring the PlayStation version though up to 97%. Sometimes GCC really likes it when dead code is present, even if it's not doing anything. Even if it's going to cull it, it still likes it. I think that's going to be it. We got a little closer. We were at 90. We're now at 93.3 on the PSP. Much closer on the PlayStation. 94 to 97. That's pretty good. The PlayStation, actually, we should be looking at maybe a little more closely tomorrow. So we do have a difference here. Different music. Between the two, I should go grab those music IDs and see which one is which. But the other part of that is looking at where we're seeing more significant instruction differences, and that will tell us kind of where we need to focus on, and may help identify some of these trickier spots. Even if we don't get it correct on the PSP, maybe we can get it correct on the PlayStation. Other than that, the PlayStation is looking pretty good. I'm going to copy this back over since I made that if def change. We can get both those correct. But that's it. Go to soten.z.dev. Thanks everybody for showing up. Sorry I've been away for a while. I'll try to be on the more regular, but we'll see. Adios.